Today we will start the second chapter of our networking series. So, welcome to a new video. This is chapter 2, data link layer. This chapter is all about data link layer. It's one of the most important layer in the WSI model. So let's start. The data link layer, a brief overview, a brief description or definition of data link layer. Here it is. So the data link layer is the second layer of the WSI model and is responsible for reliable data transfer between adjacent network nodes by managing code detection, correction, the flow control, etc. And there are some errors, some like mainly two types of error in the data link layer. Those types are single bit error and burst error. So errors in the data transmission, errors can be occur due to noise, interference, or signal degradation, and which are typically classified as the two types, like single bit and burst. So what is single bit? Only one bit in the data unit is altered. This is single bit error. And number two is burst error. Altered. Sorry, multiple bits are altered in a sequence. Then framing. Framing is the process of dividing the data stream into manageable units called frames, which are then transmitted over the network. Okay, so this is framing. Like this is framing. It's the process, simply the process of dividing the data stream into manageable units. Like each and every unit will be manageable. Those units are called frames, which are transmitted over the network after that. Then we will come to the stuffing, like character stuffing and bit stuffing. Those are really important, and you have to understand both of them because in computer networking, the practical portion will become within like character stuffing and bit stuffing. There will be some programs, like some C programs, will be provided from your college or university in character stuffing or bit stuffing. So the practical portion is based on both of the stuffing. So let's see, the character stuffings involves inserting special characters into the data to indicate the start and end of the frame. If these special characters appears in the actual data, additional characters are stuffed to differentiate them from frame delimiters. Okay, and bit stuffing, similar character stuffing, similar like character stuffings, but operate at the bit level. If a specific pattern of bits for flagging frames appears in the data, extra bits are inserted to prevent confusion with the frame delimiter. Okay, now let's come to another important question. This is error detection and correction method. You may have heard this term, error detection and correction, and it's one of the most important one. It's an important question, really. It came in the year 2017 in the semester exams of math out. So let's see what is error detection. The priority check error detection. It in the error detection part we have some like how we can check the errors and detect the errors. This is mean what the name suggests, detection. Like how we can detect the error or check the error. There are some, we have some systems to check the error or detect the errors, like parity check, CRC or cyclic redundancy check. Third one is checksum. Okay, so firstly we have parity check. Parity check adds a parity bit to ensure that the number of one in the data is even or odd. So it is a method of error detection. What it does, like it adds a parity bit so that it can ensure the number of one in the data. And what is the number of one? It's even or odd. It should be either even or odd, and based on this we will detect the error. Second one is CRC, or cyclic redundancy check, a more advanced method that uses polynomial division to detect error in the transmitted data. So it's also a procedure to detect the errors. Third one is checksum. Sum up the data values and sends the sum with the data for verification at the receiver's end. Then we have error correction. And in the error correction, we have two procedure like Hamming code and forward error correction. Hamming code adds redundant bits to the data, can be used to detect and correct single bit error. Second one is forward error correction, or FEC. FEC, or forward error correction, includes redundant data that allows the receiver to detect and correct error without the need for transmission. So those are the two types to correct the errors. In the error detection, we have some procedure using which we can detect the error, and now we have two procedure is the Hamming code and FEC, or forward error correction. Using those two methods, we can correct the error after detecting the error using those three procedures, and any of these three procedures that we have learned in the previous part, like just now. So let's come to flow control. Flow control mechanisms ensure that the sender does not overwhelm the receivers with too much data at once. Commonly, method includes the flow control method includes stop and wait, sliding window protocols, and yeah, we know it as ARQ, stop and wait automatic repeat request. So let's see. Flow control. Flow control, we just saw that flow control mechanism ensures that the sender does not overwhelm the receivers with the too much data at once. Okay. And so first method is stop and wait. The sender transmits one frame and wait for an acknowledgement. Like there are two senders, like sender A and sender B. When sender A sends a message or sends a frame to the sender 2, and sender 1 will wait for an acknowledgement from sender 2. Like an acknowledgement is a verification, like when we verify, like when we register in some websites, and verification email is provided to us, like, right? So this thing is like this, like sender A is waiting for an acknowledgement so that he will be ensured that say sender 2 is totally uh, received the frame provided by sender A. And after receiving the frame, sender 2 will give the acknowledgement to sender A, so in order to ensure that he received successfully, he received that frame successfully. So the sender transmits the email and waits for an acknowledgement. And this is the stop and wait protocol. The receiver, before sending the next frame, like he sent a frame and wait for the acknowledgement before, and after getting the acknowledgement he will send the second frame, and so on. Then the sliding window protocol, or sliding window method, this method allows multiple frames to be sent before needing an acknowledgement, improving efficiency. It's unlike the stop and wait method. Sliding window allows multiple frames to be sent. Like in stop and wait, we see one by one frames will be sent, and after getting the acknowledgement. But in the sliding window, we see that multiple frame can be sent at a time, and there is no needing to wait for getting the acknowledgement. And so generally it's improving efficiency, because we don't have to wait, the center A don't have to wait too much longer. So it basically improves the efficiency as well. The protocol, what is the protocol? Stop and wait protocol, ARQ. ARQ is a simple flow control. It's a simple flow control and error control protocol. What is flow control? The flow control In the sender sends one frame at a time and waits for an acknowledgement, just like the stop and wait protocol. An acknowledgement before sending the next frame. And error control. If the acknowledgement is not received within a certain time frame, indicating the frame might have been lost or corrupted, the sender transmitted, retransmitted, the sender retransmits the frame. Okay, so let's see again. If the acknowledgement is not received within a certain time frame, if the acknowledgement is not received with a certain time frame, it indicating the frame might have been lost or corrupted. Like you can understand if the acknowledgement is not received with a particular time, so the sender A can assume that the frame he sent to sender B might have been lost or corrupted in the way before it reached to sender B. So the sender A retransmit the frame, and this process continues until the frame is successfully received and acknowledged. So sender A will continue sending the frames to the sender B until he gets an acknowledgement and ensures that the frames is successfully reached to this receiver B. So this is the whole steps, and thank you for watching. This is all about the second chapter, data link layer, and it's enough for your university and college exams, semester exams. So thank you for watching this video. Stay with us, subscribe to our channel, and if you like this video, give a thumbs up. Bye.